Next we will discuss about non-static methods. Till now we have discussed about non-static variables. Now we will discuss about non-static methods. So what are non-static method? What methods are called non-static method in our class? The method which doesn't have static keyword in its prototype is called non-static method. Like non-static variables, we have non-static method. Also, both non-static variables and non-static methods should be called only by using object. I will make a note about this, then we'll see programmatically. The method which doesn't have static keyword in its prototype is called non-static method. Like non-static variables, non-static methods also should be called only by using object. We will see how to create non-static methods and how to call non-static methods. We will see one example. Just go to Notepad, create a new class sample 06. This is my class. Inside this class, I will create some non-static variables. Int x is equal to 10 and int y is equal to some 20. These are my non-static variables. And now I will create a non-static method void sum print xy. This is my non-static method. So in this I will write system.out.println. Here I want to print x. I will write one more system.out.println. Here I want to print y value. Now I will create a main method. Public static void main. Inside this main, string array args. Inside this main method, I will create my class objects sample06, sample06, sum s1 is equal to new sample06. I have created my sample06 class object. I want to create one more object sample06 s2 is equal to new sample06. Here I have created two sample class objects. Now I want to call this printxy method by using this two objects reference. How we can call? By using sample first, by using our first object. Our first object reference is S1. By using this S1 reference, I have to call my print xy method, and by using S2 reference, I have to call my print xy method. This is how you can call non-static method by using object reference. So you will get a doubt like, in our sample class we have two non-static variables x and y, and we are calling print xy method by using two objects. How it will create memory for our variables? You will get a doubt, because here we are calling with two objects reference, we are calling this print xy method. We will see, I will explain you with JVM architecture how it internally works. First we will execute this class. Just save it, Ctrl S, sample06 dot java. Now we will execute this class, javac sample06 dot java. Here I have written O, this is 0. Just save it, go to command prompt, javac sample06 dot java. Now it has successfully compiled. Now I will execute java sample06. Here it is printing 1020 1020 two times, but here I have only 1020 x variable and y variable. Why it is printing two times? You will get a doubt, because I will explain you with architecture, JVM architecture. What's happening inside JVM architecture means, this is my class. I will put it in paintbrush so you will get clear idea. This is my sample class. Now we will discuss about how it is executing internally. This is my JVM architecture. Here we will take heap area because we are creating objects and we are executing non-static methods. That's the reason I am explaining you in heap area. Heap area. What's happening inside heap area? We will see now. Whenever you create two objects S1 and S2, these variables will get memory. How it will get memory? First I will create this S1 and S2 objects reference. S1 object reference. s2 object reference, then it will create memory for our sample0 class non-static variables. Why it will create memory? Because we have created objects, and it will store non-static variables values inside this memory. 10 and 20 will be stored inside this. Why it is storing 2 times? Because when you create 2 objects, for every object its own copy of non-static variables memory will be shared. Shared means whatever its memory will be shared. You have 2 non-static variables. These 2 non-static will be shared with your all objects. It will share a copy to this non-static variables. So this object is having some address 1010, and this is having some address 2020, and when you call s1.printx, this printx method is pointing to my s1 object because you are calling with s1 reference. By using, when you call this printx method, JVM will search for which object, with which object it is calling this printxy method. Here it is calling printxy method is s1. Then control goes to printxy. It will call this printxy with s1 reference. Then it will check in heap area where is s1 reference. Then it will execute this data on our console. Inside s1 reference, this 1010 will be stored. Inside this s2 reference, 2020 will be stored. And when you call s2 dot, when JVM calls after execution completion of s1.printx, control comes to s2.printx. Again it will call printx method, but it will call by using this s2 reference. Then this printx method is pointing to my s2 object reference. And when it is pointing to these 2 objects, but we have 10 and 20 only one time. How this x, we are writing system.println of x and y. Here our compiler will place in place of x, it will place this dot x, and this dot y in place of that system.out.println x and y. In place of this variables, here system.out.println, inside this, for this x, our compiler will add this keyword for this x variable and y variable. That's the reason when our JVM is calling our printxy method with s1 object reference, control comes to printxy method. Here it is saying that system.out.println this dot x and this dot y. What is meant by this dot x and this dot y? This means nothing but this means this object reference. What is this object reference? S1 is this object reference. In place of this and in place of this, it will place S1. In place of this dot y, in place of this S1 will be placed in place of this dot y. Here it is S1 dot y and S1 dot printx, because our printxy is calling with S1. When control comes to printxy, Inside we have this dot x and this dot y. In place of this, it will store s1. Then it will print s1 dot x and s1 dot y 10 and 20. Same thing will be happen to my s2 method. This is how it will execute non-static methods in our JVM. For every object has its own copy of non-static variables, memory, location. And it will share same copy of non-static method. It will share Next we will discuss about this keyword. This keyword. So what is this keyword? The keyword this is a non-static final referenced variable which is used to store current object reference to store the to separate the non-static variables of different objects. Different objects will be having different copies. To separate it, this keyword is given in our Java. This is a non-static final reference variable which is used to store current object reference. Current object reference means here we have seen. This is used to store current object reference. What is our current object reference? If it is calling sample 06 s1 is equal to new sample 6, then current object reference is s1. This s1 will be stored in this keyword, and different objects will be having all non-static variables data. First I will make a note about this, then I will show you example. This keyword is a non-static final referenced variable used to store current object reference to separate non-static variables of different objects in non-static context. This is about this keyword. I will show you how this keyword will work internally. For example, we will create a class some example class. So this example class contains some data. Int x is equal to 10 and int y is equal to 20, and I am having void is some m1 method. This m1 method is printing system.out.println. This m1 method is printing some m1. Next I will create one more method, void print xy. This print xy method is printing system.out.println x and system.out.println y, and I'm calling this m1 method here. We can call non-static method from another non-static method directly with its name because both are non-static methods, right? So this is my class and methods. So this is the class which is written by developer. Written by developer. This class is written by developer. But how compiler will generate bytecode? How this class will be added with this keyword? This keyword will add compiler to our class. Where compiler will add this keyword in our class, I will show you. Class, same class, I'm creating the same class, but I'm creating compiler generated class. This is my example class which is generated by our Java compiler. Int x is equal to 10, int y is equal to 20, void m1, system.out.println inside this m1. Next we have void print xy, system.out.println. Here in print xy method, for this x non-static variable, whatever the developer written is system.out.println, just x he has written in our code. But when compiler compile this code, our compiler will add this to this x variable, this dot x, and system.out.println this dot y, and this dot m1. It will add this keyword to our non-static variables which we are printing from method. This is my class which is generated by compiler. Compiler generated code. So compiler generated code will be having bytecode. Bytecode we cannot understand directly. If you want to see the compiler generated code, whatever the bytecode we have after compiling the Java class, that bytecode you have to decompile it. After decompile it, you have to see the program. Then you will see this keyword in your compiler generated code. Here it has added this keyword. Why? Because the keyword this is a non-static referenced variable we have discussed. It is used to separate the non-static variables of different objects in non-static context. Now if you are creating example class object, in place of this, for example, I am creating example e1 is equal to new example. Then in place of this, e1 will be stored. Then one separate object will be created with this e1 object data to store this e1 object data. This dot x and this dot y will be replaced with e1.x and e1.y. Then in e1 object reference, x value and y value will be stored. Then here we have seen already. In place of this, it is adding s1 and s2. Same thing we are going to discuss here. This is my compiler generated code. And here it has created sample s2 object. For sample s2 object, it has created in place of this dot x and this dot y, it will replace s2.x and s2.y. Then inside s2 object also it will store x value and y value. This is how this keyword works in our Java.